Hello folks, today we're going to be talking about net ionic equations. So what in the world is a net ionic equation? Hopefully you remember and you studied this. What we have to do is come up first with a full ionic equation. Now remember, you're looking at things that are aqueous. Remember, things that are aqueous break apart. So over here we have zinc, and let's try that again. We have zinc. And we have one of them, but remember, zinc has a 2+ charge. We can look that up on our periodic table. That's one of the transition metals that always takes on a +2 charge. And we have chlorine. Now remember, with chlorine takes on a 1- charge, but there are two of them. We don't write that as Cl2 because it's ionic and it breaks apart when it's aqueous, and so because it's aqueous it breaks into 2 chlorine atoms. All right, we also have sodium sulfide, which is aqueous. And here we have 2 sodiums, and remember, Na has a 1+ charge, and sulfur has a 2- charge. Right? So that is, and all of these are aqueous. So all of these are dissolved in water, and I'm going to avoid writing all the parentheses just because I'm lazy and I don't want to waste your time. Right? Now over here we have something that's a solid, and remember, the solids we don't break apart. So we have zinc sulfide, which is a solid, so it stays together. And then we have sodium, which is over here, and it has a +1 charge, and we have chlorine, which has a negative charge. All right. Now I just realized, looking at this equation is not balanced, because I've got 2 chlorines and 2 sodiums on the left, but I only have 1 on the right, so I need a 2 here. When I put that 2 there to balance it, I need 2 sodiums here and 2 chlorines here. Right, and both of these, of course, are dissolved in water, so these are aqueous. Right. So as I look over here on the right, I've got 2 chlorines that are both aqueous, and over here on the left, I've got 2 chlorines that are negatively charged that are both aqueous. I also have 2 sodiums over here that are both aqueous, dissolved in water, and the same thing over here. I've got 2 of them. And then I'm done, because over here I have a solid. So if I look at this as a net ionic equation, what we've done so far is the full ionic equation. We're going to have zinc sulfide over here on the right, which is a solid, and what makes that up is zinc, which has a 2+ charge, which is aqueous, and we're going to add that to sulfur, the sulfide ion, which has a 2- charge, and it also is aqueous, and so that is our final net ionic equation for problem 1. Oh, we never did make sure it happened. Well, we'd already figured out it happened. We'd already done that, so we're not going to do that again. All right, so now here we actually have to figure out to make sure that this actually does occur. So we have ammonium phosphate. So let's look up ammonium. Ammonium is the second one across. Now we're going to phosphate, and ammonium phosphate is right here, which is aqueous. Right, and then we have silver nitrate. Remember, all of our nitrates are aqueous, so ammonium nitrate and silver nitrate are both going to be aqueous, because we said that anything with nitrate is aqueous. But the other thing we're going to have to produce is this thing over here, which is silver phosphate, which is going to be a solid. So that's our key to this, is silver phosphate, which is going to be a solid. So remember, our ammonium and our silver are going to replace each other. So I'm going to end up with silver phosphate, PO4, and ammonium, NH4, and that's going to be with nitrate, NO3. Alright, now ammonium is a +1, nitrate's a -1, they cancel each other out. Silver's a +1 and phosphate's a -3, so I need 3 silvers here. So when I put 3 there, that means I need 3 silvers over here. That means I need 3 nitrates and 3 ammoniums, which, by the way, I have on the left. So I'm all good. Everything is now balanced. All right. So what do I have as far as a complete ionic equation? Well, I have ammonium, which is NH4, and I've got 3 of them, and they are positively charged, and they're aqueous. And I have phosphate, and I have one of those, which is PO4. It has a 3- charge, and it also is aqueous. And I have silver nitrate, so I have 3 silvers, and those 3 silvers are all positively charged. And I have 3 nitrates, and those 3 nitrates are all negatively charged. And that produces Well, we said that our silver phosphate was a thing that was going to be a solid, if you remember. And over here, this thing's aqueous. Remember, we also said these two are aqueous. Remember, anything with nitrate's aqueous. And we looked up ammonium phosphate and found out it was aqueous. So the silver phosphate is going to stick together. So that's Ag3PO4, and that's a solid. But we also have 3 ammonium ions, which are positive, which are aqueous, and we have 3 nitrate ions, which are also aqueous, and they're negatively charged. Alright, so I noticed that my nitrate and my ammonium, both of these over here, here is my ammonium, and here is my nitrate, and those are aqueous. Everything on the left is aqueous. So they cancel each other out, so I'm left with the silver and the phosphate. I'm going to reverse those just because it'll look prettier. So I have 3 Ag, and they're positive, and they're aqueous. And I'm adding that to a PO4, which has a 3 minus charge, which is also aqueous. And they're going to produce Ag3PO4, and that is a solid. So that is our final net ionic equation that got rid of the things that were duplicates on both sides. Alright, I've got magnesium nitrate and potassium phosphate. Magnesium, magnesium nitrate, don't need to worry about that because I know that's going to be aqueous. Magnesium nitrate. And what was my other one? Potassium phosphate. If you remember, everything with potassium is always aqueous. So potassium, I don't even remember what I was looking for. Potassium phosphate. Potassium phosphate is all the way over here on the right. So there's potassium phosphate. And so that means I'm going to get potassium nitrate, and that's always aqueous. And then I'm going to get this other one up here, which is magnesium phosphate, and that's my solid. So magnesium phosphate, this is my solid, and the other 3 are aqueous. So I've got magnesium nitrate, which is aqueous, and I'm adding to that potassium phosphate, which is aqueous, and I'm producing magnesium phosphate, which is solid, that's the key, plus potassium nitrate, which is aqueous. Right? And let's look and see what we have here to make sure that we can balance our equations. We have magnesium nitrate. Magnesium is 2 plus, and nitrate's 1 minus. Potassium is 1 plus. Phosphate is 3 minus. So when I do my crisscross, I get 1 magnesium and 2 nitrates, and I get 3 potassiums and 1 phosphate. Magnesium phosphate, I get 3 magnesiums and 2 phosphates, and potassium nitrate is balanced. So now I have to go and balance my equations, and I see that I have 3 magnesiums on the right, so I have to have 3 on the left, which gives me 6 nitrates, which puts a 6 over here, which means I need 2 potassium phosphates, because I have 2 phosphates, and I am all balanced. Alright, so now what I do is I break everything up, and I say, well, I've got 3 magnesiums, and they all have a 2 plus charge, and they're aqueous. And I have 2 nitrate ions, and they're negatively charged, and they're aqueous. And I have 6 potassiums, and each one of those is positive, and they're all aqueous. And I have PO4s, which are phosphates, and I've got 2 of them, and they have a 3 minus charge, and they're all aqueous. Gee, are we bored yet? Oh, well, now we have something that should wake us up. The magnesium phosphate's a solid, so Mg3PO4, and I need 2 of them, and that's a solid. Plus, okay, well, now we go back to our aqueous stuff, which are potassiums, and there's 6 of them, and they're positively charged, and they're aqueous. And I have nitrates, which I have 6 of those, and they're negatively charged, and they're also aqueous. Alright, well, I do have a problem because I didn't do my math right. Because I've got 6 nitrates on the right and only 2 on the left. No, I don't. I've got a 3 out here, I've got 2 nitrates, I've got 6 nitrates over here. Alright, so my 6 nitrates cancel, my 6 potassiums cancel, they are on both sides, they're both aqueous. So what I'm left with is 3 magnesiums with a 2+ charge, and they're both aqueous. And I have 2 phosphates, and they both have a 3- charge, and they're both aqueous. And they are going to produce magnesium, Mg3, PO4, 2, and that is a solid. So this last thing right here is my net ionic equation. The middle one is the full ionic equation, and the top one is the balanced chemical equation. Okay, lead acetate, potassium iodide. Lead to acetate, and potassium iodide. Well, remember, potassium, everything that we're dealing with potassium is always aqueous. So I come up here, and there we go. We've got lead iodide, which is going to be my solid. So this, in fact, is going to go and produce lead iodide, and that's going to be my solid. Okay, so let's go ahead and work through this. I've got Pb, C2H3O2, which is acetate, plus potassium iodide, which is potassium iodide, gives me, well, my lead and my potassium are going to switch, so I'm going to get potassium acetate, which is C2H3O2, and I am going to get lead, Pbi, and this is the one that's going to be a solid, so I'm just going to mark that right down here. And now I'm going to go back and I have to balance my charges. Well, lead is +2, acetate's -1, so I have to have 2 acetates to offset my lead. Potassium and iodine are both 1 and 1. 1 and 1 for potassium and acetate, and 2 and 1 for lead and iodide, so I have to put a 2 over there behind iodide. Now I have to go and balance my equations, and I'll notice I have 2 acetates, so I have to put a 2 here, but that gives me 2 potassium, so I have to put a 2 there. I already have 2 iodines, so I'm good there, so I now have a balanced chemical reaction. These things over here are aqueous, both of them are aqueous, and the potassium acetate is also aqueous, which leaves me potassium iodide, lead iodide, which is a solid. Alright, so let's go and create our full ionic equation. Oh wait, did we balance? We have 1 lead, 2 acetates. Yeah, we're good. Okay. I have Pb, which has a 2+ charge, and it's aqueous. And I have 2 acetates, C2H3O2, and they are both aqueous. They both have a negative charge. And I have 2 potassiums, both of which are positively charged, and they are aqueous. And I have 2 iodines. They're both negatively charged, and they're aqueous. And they're going to produce, now we still have something that's aqueous over here, so that still needs to be split out. 2 potassiums, which are both positive, which are aqueous, and 2 acetate ions, C2H3O2, and those are aqueous. And then we have this PBI2 actually, which is a solid. So it has not broken apart, so we just leave it as a solid. Well, we notice that we have potassium and acetate over here, and here we have potassium, 2 potassiums, 2 acetates. They're both aqueous, they're both ions, the charges are both the same, so they cancel each other out. So we are left finally for our net ionic equation with Pb, 2+, which is aqueous. And we add that to 2 iodine ions, which are iodine negative, and they're aqueous. And we are going to produce PbI2, which is a solid. Alright, and that's our net ionic equation. Alright, that's it, folks. If you have questions, please see one of us in class. We'll be happy to help you. Have a great day, and we'll see you soon. Bye-bye.